I think I fixed the slides with the little quirks on there. For whatever reason, it didn't like to save things. Anyway, so now we're going forward. We've gone through several mole calculations. I went through 6. I went from moles to atoms, atoms to moles, grams to moles, moles to grams, grams to atoms, atoms to grams. Right now we're going to go through chemical formulas, and we've talked a little bit about it a while back, but now we're going to use chemical formulas here and give you a little bit more information about them. The next set of slides after this will go through how to calculate chemical formulas, how we can determine them. Once you go through the second set of slides, then you'll be able to do homework 4. So chemical formulas, as I said, represent compounds. The smallest piece of a compound is a molecule. And there are symbols and numbers, and the numbers go with what immediately precedes the number, and we don't bother to write a 1. So for example, well, there's a couple different types of formulas. There's what's called an empirical formula, which is pretty much almost everything we're going to do in this class. And empirical means from data. In the next PowerPoint, we'll go through how to calculate them, and experiment 5, you'll pretend you're doing it, right, because you're not actually going to be in class, at least during COVID. Anyway, but the empirical formula has the elements in the lowest whole number ratio. So H2O is hydrogen and oxygen in a 2-to-1 ratio. Al2O3 is 2 aluminums and 3 oxygens. CH2O is 1, 2, and 1. All right? Now another type of formula is a molecular formula, and the book does more with this than I do, and I don't do very much of it. But it's a little bit different because we say how many of each element. So an empirical formula is the lowest whole number ratio. So for example, from the empirical formula CH2O, which is the formula of all the carbohydrates, you may have heard of carbohydrates, these are a couple molecular formulas that have that same ratio of 1 to 2 to 1, right? C5H10O5, C6H12O6 are all, those are molecular formulas with this empirical formula. Right? And then the third type, and we don't do much with this. Third type we'll do much later, and when you go do organic chemistry, all right, it's called a structural formula. It gives you the arrangements. So just for example, here's the empirical. Here's a molecular. This is what the structural formula would look like. And so you can see the carbons are attached to carbons, and there's an oxygen here. But if you count, there's 1, 2, 3, 4, 5 carbons. There's, for hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the oxygens, 1, 2, 3, 4, and 5. But you see how this tells you what's attached to what. We will do some very simple ones much later in this course. We won't do anything this complicated, but this is the kind of stuff you do in organic and biochem. And for those of you here, this is ribose. All right. Now, what's interesting about the formula is this is called the law of definite composition, if you care about the names. The formula is good no matter how much of the compound you have. So, for example, 1 molecule of Al2S3 is a 2 to 3 ratio of Al and S. So there's 2 aluminum atoms and 3 S atoms per molecule. In a mole, there's 2 moles of aluminum and 3 moles of sulfur. So you see how the ratio 2 to 1, 3 to 1, 2 to 1, 3 to 1 is the same. But also, if it's a mole, you have Avogadro's number of molecules, which is kind of cool. All right. Now, the molar mass of a compound, so we got Avogadro's number here. Molar mass of a compound is the algebraic sum of the atomic masses. So what you simply do is you take the subscript and you multiply it by the molar mass of the element. So aluminum is 26.98. In Al2S3, there's 2 aluminums, 3 sulfurs. These numbers are from the periodic table. I do the math and I add them up. So the molar mass of Al2S3 is 150.14 grams per mole. But if you're going to do calculations, you might want to write it like this: 150.14 grams of Al2S3 per mole of Al2S3. Here's something with parentheses which we haven't dealt with. And why do we have parentheses? That's something you'll see when we go through nomenclature. And so we'll just leave it for that. But it distributes through. The subscript goes with whatever immediately precedes it, so 2 goes through. So why don't we write it MgO2H2? I just said we'll get back to that. But there's 1 magnesium, there are 2 oxygens and 2 hydrogens. Molar masses from the periodic table. Do the math, add them up. And so the molar mass of this is magnesium hydroxide is this. And again, when you're doing problem solving, it might be a little smarter to write it this way, and again, those should be subscripts. In the formula thing, it doesn't look subscripts. I'll try to fix that as well. All right, so I'll let you just give you a minute, see if you can determine the molar mass of, this is called calcium phosphate. So hit pause, try it on your own. I'm going to count to 5 and then I'll go through it. All right, did you do it? Did you get it? Okay, I'll go through. So you make a list of the elements. There's calcium. There's 3 of them, and it's 40.08 from the periodic table. Phosphorus, there's 2 of them, 30.97, so 61. Oxygen, there are 8 of them, and so it comes out to be 310.18. All right. So just to summarize, if you had a molecule of this stuff, calcium phosphate, you'd have 3 calciums, 2 phosphorus, and 8 oxygens. A mole has 3 moles of calcium, 2 moles of phosphorus, 8 moles, so these numbers are the same, but for a mole, you have Avogadro's number, and you can use the molar mass. So I could use any one of these 5 things in a ratio to this. So I could have 3 moles of Ca per mole of that, or whatever. Now, how do I know what to use? Well, we've talked about conversion factors before. You just use whatever you need. All right, so the next few slides are going to be some problem solving using for molecules. All right, it's the same, exactly the same approach. The only difference is that you've got to use, you have to calculate molar masses. So let's do this one first. Here's the rubric just to remind you. Again, I apologize for my handwriting. So we're going to do how many moles of CO2 in 1.75 times 10 to the 19th CO2 molecules. All right. So same approach to problem solving. First thing you want to do is write down the units of the answer. The question is how many moles. And notice I don't just write moles, I write moles of what. Right, then we're going to say, well, we're starting with the 1.75 times 10 to the 19th. So we want molecules to moles. So if you look at this, I have particles, I want to go to moles. I don't need to calculate the molar mass in this problem. And it's important to know that. Why would you calculate it if you don't need to? All right, so then we do this, and we put Avogadro's number in this case, because Avogadro's number will have molecules. We want it in the denominator. And so then just do the math. And that should be the answer. Again, once again, make sure your calculator will give you this answer, because if you're doing it wrong, it's going to show up. So we want to fix that early, and I have Zoom sessions. All right, see if you can do this one on your own. Now, you can hit pause. I'm going to walk through it. All right, so we want the answer is going to be in grams, because it says what is the mass. So then we're going to start with what we're asked. So now we want to go from moles to grams. So what do we need to go from moles to grams? Relationship between grams and moles is called the molar mass. You want to make sure that you can calculate. I'm just doing these now, but you make sure you can get that number. And again, a little thing about molar mass is you can calculate them to lots of digits. So just look at the question. I need 3 sig figs here, so I'm going to calculate the molar mass to 4. Because I want this to drive my rounding, not a number that I can look up. Because handheld calculator, pushing one more button is not a big deal. Okay. All right, let's try another one. So the mass of 9.581 times 10 to the 21st P2O5 molecules. I'm going to count to 5. You can hit pause and try it on your own. All right. You're back. So we'll walk through it. First thing we want to do is write down the units of the answer. The question is mass, so we want grams. All right. Now we're starting with the molecules. So we have molecules go to grams. So we don't know the mass, so we can't do this in one step. So you can work it backwards or you can work it forwards. Let's just do it this way. I'll work it backwards. Okay, I want the unit grams. I can always, if I know what the formula is, I can get the molar mass. All right, so make sure you can calculate that on your own. So now I have the right unit in the right place, but now I need molecules and moles to cancel out. So what do I use to relate molecules to moles? A hint. What's guacamole made from? That's right, avocados, which sounds like Avogadro. So we use Avogadro's number here. We want it in the denominator because we want molecules to cancel. See how molecules cancel and moles cancel. So our answer comes out in grams. Once again, make sure you can get the right answer on your calculator. All right, this is the last problem we're going to do in this set of slides. And you'll notice this problem's a little bit different because every other problem we did, I asked you about the same substance, right? Even on this one, I asked you about P2O5 and I told you about P2O5. But here, I'm asking you about silver, which is Ag, but I'm telling you about silver sulfate, Ag2SO4. But you can use the same approach to problem solving. So this is where it's very handy if you can work backwards or forwards. So I'm going to go ahead and go through this, but if you want to hit pause and try it on your own, knock yourself out. So I'll just wait just a couple of seconds here before I start. You can hit pause at any time, obviously, and try it on your own. All right, so we want the units to be Ag atoms because the question is silver atoms, so we want just the Ag. And we're starting with the 126.88 grams of Ag2SO4, so we're setting up the problem like this. So you can work backwards or forwards, it doesn't matter. So let's see what I chose to do here. I said, where can I get the unit atoms? Well, I can always get atoms from Avogadro's number. This is where it's really important to not just write moles, but moles of what? So I have the right unit in the right place, but that's Ag atoms per mole of Ag. It's always the same substance with Avogadro's number. All right, so we got the right unit in the right place, but these don't cancel. How can I make grams go away? That's right, I can use the molar mass. So I calculated the molar mass. Again, make sure you can do this. I need grams on the bottom. So now I have moles of Ag2SO4. And this is, again, if you just wrote moles, you might not notice that these are not the same. This is moles of Ag. This is moles of Ag2SO4. So what you need is the relationship that has moles of Ag on the top and moles of Ag2SO4 on the bottom. And so you need to know the relationship between moles of Ag and moles of Ag2SO4. And that's right, there are 2 moles of Ag in a mole of Ag2SO4. How do we know? Because that 2 right there, that's what it tells us. So now you can see the units cancel. So this is a really good example of not just writing grams, but grams of what? Not just writing moles, but moles of what? And if you were a little sloppy, say, and you didn't write moles of Ag2SO4, you just wrote moles, and you just wrote moles here, you would not know that you needed to do this step. It's a very common mistake. So it takes a half a second to write Ag instead of just moles. All right, so that's the last problem here. There's a lot of this on homework 4. You can start homework 4 now, and when you get up to the questions about calculating an empirical formula or a percent composition, you can just wait and or go through the next slides first. I'm going to try to do a couple of optional Zoom sessions. It's just scheduling wise, but you can always come up on Zoom if you have questions about these. All right, stay tuned for the next set of slides where we can go through how to calculate an empirical formula and what a percent composition is.